Let's show how to solve for quadratic solutions by completing the square. And we see that we are not solving for the roots of this quadratic because we are not setting it equal to 0. Rather, we're seeing, does this quadratic function ever intersect with this linear function? And if so, at what x value does that happen? That's what we mean when we set them equal to each other. We say, is there a place where the value of y, the value of the entire thing, will be equal to the value of y for some given x, where they can agree on some coordinate x and y. So this thing is a quadratic that opens up. And this is a linear function with a negative slope. And we are trying to see, can we solve for some intersection? That's why they are set equal to each other. And we will be completing the square in order to try to figure out what x value might make that true. So now we'd like to get this total expression set equal to 0. So let's add 3 to both sides. Let's add 2x to both sides. So that now we have 0 on the right-hand side. And on the left side, we have 2x squared minus 8x plus 10. Now, in order to complete the square, we want to be working with 1x squared, and right now we have 2x squared. So in order to be working with 1x squared, we will divide by this 2. If we divide this by 2, then we need to divide everything by 2. That's on both sides of the equation. So now we have x squared minus 4x plus 5 equals 0. Now what we would like to do in order to complete the square, we would like to blank out this term so that we have x squared minus 4x and then plus some other number that is not 5 in order to get x minus something squared down here. So in order to blank out this space, we'll have to subtract the 5, and we'll have to do that to both sides in order to make sure that the equal sign continues to tell the truth. Now we'll say x squared minus 4x plus something equals negative 5. And in order to figure out that something, we need to figure out what would go here. So we can think about, well, how would we get to x squared minus 4x by having some binomial squared? What we're saying is that we would have some x squared with a total of negative 4x here, where this is the same as this, so we could have this be the same as this. So then we'll take this negative 4x and divide it by 2 and say this is minus 2x and say this is minus 2x. So then this is x minus 2 and this is x minus 2. And we see that when we multiply x minus 2 times x minus 2, we get x squared minus 4x. But then we have this other term, plus 4. And that is what is going in the blank here. If it goes in the blank here, it also needs to go in the blank here. Because what we're doing is we're adding this 4. If we add it here, we have to add it here so that the equal sign continues to tell the truth. So what is this x squared minus 4x plus 4? It is x minus 2 squared. They are the same thing. And this equals negative 5 plus 4, negative 1. Now we see that all of our variables have been captured in this argument. We don't have any loose variables escaping, and now we just have something squared equals a number. So now we can unlock this variable by taking the square root of both sides. Where this 2 reminds us that we're going to be looking for two solutions. So we're taking the square root. If I do it to one side, you have to do it to the other so that the equal sign is still true. So if you're keeping score at home, and I know you are, this is the square root of x minus 2 times x minus 2. This is the square root of negative 1, which we should recognize as a special number. We should also now say we've taken the square root of a negative number, so we expect that our solutions will be imaginary. And if we're right about this and our solutions are imaginary, that means that these don't actually touch each other. Let's finish the problem. The square root of x minus 2 times x minus 2 is x minus 2, and that equals plus or minus the square root of negative 1, which we say is plus or minus I. The square root of negative 1 is called I. And we finally get the x by itself, or we solve for x by adding 2 to both sides and say x equals 2 plus or minus I. Or if you prefer to write the two solutions, you'll say x equals 2 plus I. You'll also say x equals 2 minus I. And you have done it! You have solved and gotten imaginary intersection, imaginary solution, answering the question, does this intersect with this in the xy coordinate? No, it does not. Congratulations!